How can I solve a system of equations by using elimination? So what elimination is basically we want to get two equations to the point where one of the variables has opposite coefficients, so that way we can basically add or subtract them. So in this case, we add these two equations together, and you can see that if I have positive 5y and negative 5y, it becomes 0, which leaves me with 5x equals 30, and I can divide both sides by 5, and I get x equals 6. Once I have x equals 6, I can substitute back into the other equation of 2x, so 2 times 6 plus 5y equals 10, and I can solve that to get that y equals negative 2/5. I can then check that back in this same equation, or I can use the other one too. Doesn't make a difference, but I can check that to verify and get to 20 equals 20. So I know my solution would be 6, negative 2/5 would be my x and y coordinates for the intersection point of those lines, or the solution for that. However, when we have a system of equations, we don't always get a nice pair of equations that work out. So there's a set of 6 steps that'll get us back to that point that I just showed you. If you wrap each equation in parentheses, so if I take these two equations right here and I wrap them in parentheses, and for the purpose of this, we're going to call one the top equation and one the bottom equation. And for step 2, you're going to pick a variable from the top equation, so that'll be this one. This will be my top equation, and this will be my bottom equation. To eliminate, identify the coefficient and the opposite of the coefficient. So I'm going to pick the y variable, and so the coefficient of the y is 14, and the opposite of that would be negative 14. So negative 14 is the opposite of the coefficient of the variable I'm going to choose to eliminate. Apparently I have these out of order. Step 3. I'll come back to step 4. Multiply the opposite of the coefficient by all of the bottom equations. So here's my top equation again, and here's my bottom equation. I take the coefficient of negative 14, the opposite of the coefficient of negative 14, and I multiply that by. So negative 14 times 6 is 84, so I have 84x. Negative 14 times negative 7 would be positive 98, so now I'm going to add 98y. And negative 14 times negative 10 is positive 140. So this equation, I'm going to come back to it later, but I'm going to kind of set that aside for now. And I'm going to go on to step 4 and 5. So in step 4, we take the coefficient of the same variable in step 2, but from the bottom equation. So I come back to these equations. Here's my bottom equation. Same variable. I'm going to take that coefficient from the bottom equation. And in this case, the coefficient is going to be negative 7. Step 5, multiply that coefficient. So I don't take the opposite of this one. I just take the negative 7. I multiply it by all of the top equation. That's what those parentheses are for. So I do negative 7 times 8x, which gives me negative 56x. Negative 7 times 14y, which gives me negative 98y. And negative 7 times 4, which gives me negative 28. Now, if you think back to that previous equation, it was a 98y, and now I have a negative 98y. So my y values are going to end up canceling out, and that's where I get to step 6, where you add the equations and solve for both variables. So first I add the equations. You can see my y's become 0. I end up with 28x equals 112. Divide by 28, and I get x equals 4. I still have to solve for both variables, so that's where I went back to the original equation. I substituted 4 in for x, and I got 8 times 4 plus 14y equals 4. I continued through algebraically to take 32 from both sides. I then did 14y divided by 14, negative 28 divided by 14y equals negative 2. My solution would be 4, negative 2, and I checked it over here by substituting 4 and negative 2 into the other equation from the beginning. And it worked out in with negative 24 plus 14 equals negative 10, which is correct. Negative 24 plus 14 would equal negative 10. And so it all worked out. And that would be the process of solving equations. How can I solve a system of equations by using elimination?